Test. Oh, there we go. My mic was being weird. Okay, now I think we're live. Sorry for getting a little bit of a late start here. Had to dig out the Dremel and make sure I had all the right tools. I think I do, but we're going to find out as we go. As you may have guessed from the title, we're going to be cutting some threaded rods today for the integrated lead screw on these motors. I've got two of them here that we'll be doing. At least I did have two of them. I might only have the one now. Well, I'm not. Oh, no. We do have both. We have one right here. We have one right here. Perfect. So while we're waiting for people to get in chat, Chip, if you can just give me a message when you're back in here, or when you're here. We're going to just kind of review our setup here. Take this off really quick. As I mentioned, two, count them, motors. These are the same ones that'll come off of your Mark III, but they're a little too long for our application. So we're going to be cutting these down to 260 millimeters. And I'm going to show hopefully at least two different ways to do that. Kind of a more fancier setup and a cheaper option with the hacksaw. Heyo, Kolbasaur and Dominic. What's up, guys? Thanks for joining. So this is actually a 3D printed jig that Chip recommended in one of the last streams. And we're going to be using it today, but let's just take a quick look at this if I can get it to zoom in here. Why is it not working? Oh, there we go. Okay. So the idea, actually we can unscrew the Dremel for just a second. Chip, when you're here, we might want to actually put a link to this, the Thingiverse URL in the video description. That might be helpful. But I gotta say, I really like the design of this. It's pretty much two parts, which is kind of like a third support block, but we're actually not going to be using this. So set it aside. So really two parts here. No supports needed to print this. Thought it was pretty cool. I printed it at 40% infill, so it's pretty solid. They do mention, you know, you'll need to have a 10 millimeter rod to kind of connect the axis here. So I had this one laying around. Now, I didn't want to cut this because these are a pain to cut. Like this hardened chrome outside. A hacksaw, sawzall isn't going to touch it. You need an abrasive wheel. So you have two options. One, fortunately, it doesn't have to be down to the right size. It can be too large or whatever. That's totally fine. Just insert it in. And depending on your dimensions, you might need to give a little extra push. And I mean, that's pretty much in there. But I actually thought of another way to do it as well. I wanted to show. And if you're in a pinch, I mean, you could probably 3D print a 10 millimeter shaft as well. But with the way that you print that, it's going to be very weak with where the layer lines are at. So might work for one or two applications, but I wouldn't trust it too much. But I have this cheap set of metric drill bits and, you know, a 10 millimeter cylinder. That's really all we need here. So you can actually simplify with using a drill bit. And you know what? I kind of like the idea of that, since that's going to be more available to people. So I'm just going to shove it in there like that. And now we have an operating jig. The inside of this is threaded. Don't know if you can really see, but Dremel screws in there. Struggling with it here. There we go. And you're going to want to use a This is plastic. We don't want to use the plastic one. Let me get a metal cutting blade. This one here. As you can see, this one's made for metal. So we're going to use this. Get that right. Try not to break the disc as you put it on there. Come on. And I'm having a heck of a time with that. There we go. Helps if you put it on the right way. And twist. Okay, that didn't feel right, but no, that's seated in there. This goes down, and preferably you have this lined up with this hole here. I don't think we're actually going to need that, but let's see. If we do want to line that up, I think it's just as simple as... I did have this guard that I was going to use, but since this screws directly in here, we won't have room for that. And just looking for the rinse that I've been running. Got spare, so no worries. So we're going to loosen this up. Gives us a little room to work with. Then we're going to line it up. And just so that we have that cutting into the recess there, we can get a better shot of that. Maybe a little bit of an overhead view here. I might turn the mic down or off during the cutting. I don't know if it's going to blow out the eardrums of everyone here. Yeah, so it's going to cut up and down like this. I can probably back that out just a bit more. I don't like how far in it's going. Unless, maybe I'm supposed to flip this around. If I had this going the other way. But I don't think that would work like that. Yeah, we'll go with this. I don't think there'll be too much torque there. Wait a minute. Lefty tight, lefty loosey, righty tight. It's always weird to do when it's backwards. Okay, so the other thing to note here, I actually printed this support block. And the reason for that is as we go to cut our motors, really like if I could mount this down better, but we're just going to use our hands. But when we set this down to cut it, this is going to want to, there's nothing to support this. And I didn't really like having the other side, and I've got to crank this down even more here. True, like 90 degrees. And we got a few different new faces today. Lost Ink, good to see you, man. Welcome to the stream. We're cutting some threaded rods today. Actually, this does kind of seat in there nicer than I expected. So maybe we will use this support block. Because as you cut, you want some support, otherwise this is wiggling around a lot. And that just goes directly into our motor bearing there, and I don't want to jiggle that free. But no, that actually, I didn't think this lined up as well before. But it doesn't look too bad. If you do use this support on the other end, this is kind of nice that it can go flat against the table. Then, I think we can hold here as we go down. That's not going to work because of course it won't. Why would it? Maybe we will be doing something a little different here. Okay, so yeah, I've either got to flip this around or do this a little bit differently. And put this here. Some additional support. See, it's not a full support. That's not what I'm looking for here. Let's see. What if we thread this on? And at least we have some support here. Actually, I want to do that the other way. So that it sits flush against the jig like so. But you know what? Before we go any further, let's go ahead and mark 260 mils. Now, I believe we're going to be measuring, let me set this aside. I believe we're measuring from the base of the motor, like right here. But I need to double check the CAD really quick in case we're measuring right there. I don't know if it's going to make a big difference, but I'd rather do it right. So it looks like from the base to the top, we're at 258. If we go from here, yeah, okay, it looks like that's how that's measured. So that will be the better way to do it. Or if you do measure from here, just measure out 258 millimeters. And that'll get us done. Now, you'll notice it's probably going to be a little hard to mark this. Kind of hard to see. I don't really like that idea. So I'm going to use one of my favorite tools. Not just some, oops, switch this over. And that's just some green painter's tape. I was trying to show on camera just a second ago. This, isn't going to mark very well. There's markers that'll do it, but it's kind of hard to see. But I really like to take some green painter's tape. I'm going to move this camera over here because it's right in the way of what I'm trying to do. There we go. That better? Now we've got some better view there. We're just going to take a small strip of this tape. There's two ways to do it. You can measure, and this tape can be your indicator, exactly where you need it to be. See if I can get in range of 260 here. So 260 is right here. But we're measuring 258, so just a bit under that. But if we're measuring from here, Yeah, that's not going to be as precise. So what I'm going to do is wrap this around just in the approximate area, and then we're going to mark the tape instead of trying to mark the metal. Kolbasaur, fun fact, actually used to do a little bit of metalwork and machining. So share your secrets, man. Is this the right way to do things? Is there a better way with just tools you might have at home? Or my mark right here. So we're measuring out 258. It's gonna be kind of hard to see on camera, but I'll try my best. Right around there, I believe. Get this sucker plugged in. Hopefully I've got enough room. Yeah, that'll work. And I just realized we didn't put our support block on here. Shoot. With it like so. What I'm going to do is just hold it with my other hand here. So if any vibrations are coming through, hopefully that's not going to wiggle free to the actual motor too bad. We're going to line this up. And don't forget your safety glasses. Keep it safe. Okay. I'm going to set this to about 10,000 RPMs. Hopefully that's a good start. That was a whole finger ago, Kolbasaur says. Yeah, man. Nice thing is, if you get this a little off center, well, it's a motor, guys. You can kind of turn it. You can twist it to fit what you're trying to do. Okay. And where's it going to go for here? Feels a little too slow. Let's turn that up. That's a little too crazy. Let's try 20. That feels about right. I think I'm just realizing what I'm doing wrong here. I think I do have this on backwards because the Dremel's spitting at me. And even though I've got safety glasses on, I don't really like that. And this is probably hot, so nice and easy. pull up the CAD for this really quick for the Thingiverse page. I feel like I'm not using this right. No, that does look like what they're doing here. I'll share my screen. So that's the idea. I don't really like the idea of having it fit at me, so I might just try to flip this around. Oops, like that. See if we can figure this out. That can't actually see. There we go. Now the other problem we're going to run into is this doesn't have the room to go all the way down. So, this is one method, untested, but we might end up just using a hacksaw on all of it. Oops. You can actually see on the printed part where it's eating into the plastic. So, not quite the most precise tool that I've printed, but I still like it. I like the idea of it. I don't know if Chip ever showed up for this one. Wonder if he knows we're streaming. Okay, let's try this again. That's, I think, where the limitation of this is going to come in. We can't actually continue going down because the rod prevents it from moving down any further. So we're just going to do this the old-fashioned way, with a hacksaw. Although we will probably use the Dremel later to clean it up. Let's get a view here. flip this. These are really nice. Pick this one up off Amazon. It's not too expensive. But really, any way that you want to clamp this down, keep it locked in, that should be totally fine. I'm going to take our tape off now, since we obviously know where the cut is at. And then we're going to put the support block back on there. Woo, still a little hot. Assuming we can actually get it threaded over these. Well, actually, no, we don't have to thread it on all the way. Something like this. How do we want to do this? So, whoo, I guess that wasn't down all the way. So I've just got it locked in, both spots here. And actually what I am going to do is move this all the way almost to the top. Lock it here. Even though it's a little off kilter there, it's going to give us enough room to get in there with a hacksaw. And yeah, just take it nice and easy with these. Probably. Not putting like any pressure down at all. I'm just running it back and forth, letting the saw do the work. Woo! Oh no. Be careful not to let it jump out. I mean, that'll be fine, but you don't want to mess the threads up. Yeah, we've got to be getting close, right? Yeah, we're almost there. The last little bit there is always the hardest. There we go. Now be careful, even though it is a hacksaw, it can get pretty hot. So we'll just need to clean this up a little bit, but as we can see, it's not too bad. Ooh, ooh, maybe we can see. Oh my goodness, I can't tell which way is up and left and right when I'm looking at it in reverse. But I think, pretty good job. You also, of course, can just take the Dremel and cut right here. I decided not to do that because I don't trust myself without the jig. Those Dremels can go flying pretty quick, and they can make short work of damaging your threads. You know, with our hacksaw, we slipped off once, and that's just not too bad. Sometimes you can use the, typically in these situations, I just use the nut to clean the threads up, but this is brass, so it's not a great, it's softer than our steel here. But it actually still threads on without any issues. So that means if we can thread it on without any problems, that means that our palm nut should do the same, but we don't want to mess those threads up. So we're still just going to clean this up a little bit. And there's two ways to do that. You can use the Dremel. That's just, again, sometimes it's a little too crazy for me for 3D printed parts. We don't need it to be crazy, what I'm looking for, square. That doesn't really matter quite as much. If it's off a little bit. I'm going to screw it in here. Let's zoom this out. Move it over. Okay. So you can kind of use the hacksaw to clean up a little bit of this, but what I'm actually going to do is I like to use metal files for this. Got a kit here I've used for a lot of other, well, used and abused for a lot of other types of jobs. I'm gonna grab this one. I've actually used it on wood a few times, which is not great, but it worked. And I'm going to do this from the side here. See if I can get a top-down view again. Something like that. What do you guys think? Am I zooming in too far, or is it good before? It looks good, and as soon as I let the tripod settle, it gets all messed up. Okay. No, I don't like it. It's looking kind of backwards is the problem. Still want a little bit of an angle, so we can put it back. Right about there. I am going to put our support back on there. So I have something to hold on to at the edge here. Okay. So I've got I don't know if you can see it in the other camera, but I've got one. Yeah, let's move this up over here. I don't know what I'm doing. Clear all the way over this way. I don't even know if you can see the burr on camera. It's right here. So we're just going to start trying to clean that up a little bit. Nice, nice and flat. And then we're just gonna go around the edges just a little bit so it's not quite as sharp. Oh yeah, no, you can definitely see that burr on camera now that I'm looking at it from the actual iPhone. Looking cleaner. See, we're kind of beveling the edges so that it's not quite as sharp or it doesn't have any burrs on it. What do you guys think? Looking pretty good? Not quite a factory edge, but I like it. It doesn't feel like it's gonna cut. Maybe a little lip right there still. Yeah, needle file can be helpful too. And I'm upset that I skipped and scored that right there. But you know what? I don't think we're ever gonna get. Well, I don't know. In the cat, it might get up there that far, but I don't think it's gonna affect it much at all. Okay, that feels pretty good. I am happy with that. Let's rinse and repeat. Safety squints, yep. If you have to do safety squints, you're you're in playing a dangerous game, my friend. Although, in lack of anything else, I guess it's better than nothing. Basically, just giving the debris a smaller target to aim for. Assuming it's not an actual flying piece of shrapnel that's going to go through your eyelid. Okay, putting this on first this time. And really what I should be doing is putting this up here. And then clamping this end down. Let's see if I can do that. I know I've got a clamp around here somewhere. Pardon me. Oh, you know what? We didn't measure this one yet. So back up. I guess that's the tricky part, is that it's going to be kind of hard to measure this and mark it at the same time. Or it's going to be hard to measure it if we've got this on. My wife's working on another project in the other room, and it sounds like hers is having a harder time than mine. So might have to undo this once, but we haven't permanently messed anything else up yet. Oh, well, it might help if I actually hold it right direction. Since I showed this before, I'm not too worried about getting it on camera again. You know what? I don't know if this works for metal, but for cutting plastic and acrylic and other things like that have a tendency to splinter off and have an ugly edge, putting some tape on there actually helps the cut. I don't know if that works for metal though. You guys have any experience with that? If keeping the tape on there actually keeps it from flaring out or having larger burrs? I don't know. Where did that go? Found it. Oh. So Chip, all else being equal, is it better to cut this a little too big or a little too long or a little bit too short? Just out of curiosity. Looks like if anything, it actually doesn't look like it'll matter too much. I don't think it's gonna matter if it's a teeny bit short or a teeny bit too long. I think there's some wiggle room there. So what I'm gonna do is I'm gonna mark, basically just score this. Maybe even put this on for a little bit of a better grip. And then once I have the mark on the metal, take it off and finish it off. The tape actually helps with keeping it from sliding around as well, so that's kind of nice. Actually, I don't hate that process right there, just like that, but let's move this back in. I'm not a machinist, but this part doesn't require the highest precision ever. So these little cork plugs, I forget what to call them, but I think they pop out. I think they're removable. We don't need this one. Let's try to get it out. At least I assume they are. Oh yeah, no, they've got tabs on the bottom that press in, but man, this thing is in there. I might have abused this thing a little too much in the past. I'm not the simplest tool owner. Man, they really wanted that thing to stay in there. Just don't want to cut them up too bad while I'm doing the other stuff. Come on. Doing it right here. And make the cut. And kind of hold it in place with this. Stay relatively, yeah. So we can do this. It's kind of like last time. But we'll be cutting inside rather than outside. And I'll get the camera set up here better in just a sec. So I partially pulled it out. There we go. Snap it back in. Couldn't make up its mind if it did want to come out or not. It's even harder to turn now. I think that'll be okay though. As we tighten, it should help straighten back out. Yeah. And it might break my printed part here, but I don't really care about that. It was just a quick design and half an hour on the printer. Probably didn't even need a half an hour. But... Okay. I turn it this way. Do I get a better angle? Yeah, that'll work. I'm just going to hold the screw to stop it from turning. Tip, are you on the live stream? I saw a couple messages from you in Discord. Curious if you ever got into the live stream. I was going to do this yesterday, but I didn't quite have the jig finished printing, and I was missing some of the square nuts that we didn't have enough of from last time. So I was waiting for that order to show up. Otherwise, I would have been streaming this last night. Sorry, does that sound like grating? Would it be better to mute the sound, or maybe all of you have muted it already? I can't imagine this is the most pleasant sound. No ASMR hacksaw videos, I don't imagine. Damn it, I did it again. The tape might have saved me a little bit there, though. Take it easy. Take it easy. Don't rush it. Okay, I skipped off again, but that went higher on the part that's going to be left off, so no worries. Yeah, no, this might be the first one with hand cutting a lead screw. The one in your kit, if you guys haven't seen this from last time, the one in the kit you'll get will be the right size, and maybe we can talk to Fabrico and see if we can get that as a standalone option as well to add 2 extra motors if you don't feel comfortable cutting your lead screws. But if you want to save a few bucks, reuse parts as much as possible in your conversion. This one's not too bad. Just we did include the extra linear rods because again, cutting those is a whole different ball game. You need to use an abrasive wheel or like an angle grinder, and that's no fun. I've tried to do it before. Um, it's not fun. If you have like the cutoff tool, it's not too bad, but even with that, it takes a while to cut through that hardened steel. Good heavens, why am I skipping off? I might need a new blade soon. This one's getting dull. Uh, we're about halfway done. Woo! We're getting closer. Getting closer. And starting to cramp up. Okay, I think we're just about through. So I'm going to start slowing down a little bit. I feel like this one's taking a lot longer than the last one. It's also getting pretty warm, so let's just give that a second cool down. As the metal heats up, you don't get as much friction between the blade and the material. Same reason why on trucks or cars, I guess, anyway, too. When your brake rotor heats up, the brakes stop doing their job because they can't create as much friction. I feel it getting closer because I can feel it cutting through a thread and then dropping down a little bit and cutting through a thread and dropping down. So we're getting real close. Just about there, guys. Haha! Woo! That was a little bit more work than I was expecting on that one. How's our cut look? Definitely not as pretty as the last one. See if we can get a shot here. That's the hardest thing. So because I was rotating it, which I was trying not to do, we get some of this stepping that occurs. I don't know if that's the right word for it. Not a huge deal, but doesn't look quite as pretty as the last one. Let's see if I can get a better shot now. Every time I go to do that, I just can't figure out which way to turn it. Maybe this will help. All right, you know, I'm just gonna come on the other side of this. It's easier when up is down, or it's easier when up is up instead of down. There we go. So that's what it looks like. Got a little burr there. You're always gonna have a little burr at the end, and that's kind of the stepping I was talking about. Not a huge deal, but let's see if our brass nut will go on there without needing any help. Yeah, it goes on. A little bit of resistance, but we'll clean that up. As far as the spot where I skipped off, I can't even tell where that happened. Maybe right here, but I think it looks pretty good. Zoomed in so far, it's hard to tell where it's at. So it would have been on the first like 2 or 3 threads, and we're looking pretty good there. So even though it wasn't perfect and I skipped off a couple times, not a big deal. Let's clean this puppy up. Well, we want to do this with a little bit off. Over here. Same as last time. And instead of trying to move the tool around, I'm just slowly rotating with my thumb and finger here. And you'll feel when you're on a rough spot, the whole tool will kind of vibrate. Once it evens out and smooths out, you know you've got a clean edge. Small lip still right about here. All right. Take a look at that. Yeah, digital zoom's not so friendly, but let's take a look here. No lips. Nothing that's going to gum up our threads. Not totally square, but again, not a big deal. Whoop. I don't need to worry about the brass yet. Okay, we have two motors that are cut within about 1 millimeter of each other. And that is probably the most hands-on and custom work you'll have to do for this build. Set this aside so I can clean it up later. Okay, get some of this stuff out of the way. And a beverage break. I'm not sure if there's, I'm sure there's some point to keeping these. So these might just go in a spare parts bin somewhere. Maybe for, I don't know. There's some tool changers that use threaded rods that are about, a little bit smaller. I don't know if these are the right size for that, but should be pretty close. You can tell we got pretty close on the lengths here because these are pretty much the same length. Zoom out just a touch. On the other side of the camera. So they are, pretty much even, within 1 millimeter, if not less. We're gonna stack these in our parts tray. Here, this goes with the Dremel. Okay. Unplug this so it doesn't find a way to turn itself on and wreck something else. Okay, guys, we're gonna finish the Z-axis for real this time. don't need this right now. One thing to working efficiently, kind of found, is try to keep your workspace free of any other material you don't need. So that when you go to grab the piece you need, you don't have to hunt through a bunch of different bags of stuff or parts. Helps to be able to visually find what you need a little bit quicker. For me, is a big deal because I set something down and promptly forget where I set it most of the time. Okay. These aside, we'll come back to these in just a moment. Pull our frame back out. And one thing we're going to do really quickly, I was going to try to do this off camera. I guess I don't need my safety goggles no more. But I'm going to bore you guys with it instead. Got to do it either way, and let's just do it with the content. So what we did is grab these parts here. If you were here on the last stream, you noticed that we tried to thread our screws in here to hold the rods in place, to clamp them down, and the square nut was placed just a little too far back to engage the threads. I probably could have done it if I had, pressed it up against the slot, but Chip redesigned the parts so the slot is a little bit closer, so the screw should have no problem engaging with that. Bring this back down. Trying to get a view here. Yeah, something like that. So what we're going to do, we're going to kind of replace these in place. So just one at a time. I did one of them already just to check and make sure it would work. So we don't have to do all of them, but loosen. Get the full shot here in frame. If we back it up a little bit, we can. We're replacing this side. And so we don't get messed up, we're going to... Guess that was one where I did have the square nut in there. But I've got a brand new set. Bunch of them here, so we've got plenty. Once we take that off, actually let's prep the old part or the new part. I think this is the part I just took off. Try to keep those separate so I don't lose track of it. Got 1, 2, 3, 4, 5, 6. Perfect. Now curious if this will show up on camera. Probably not. But oh, actually, so there's two changes to this. No, I did like this down here a little bit better. So you can see the big picture from the main camera. This one's job is to give close-ups. So I think these are the same parts, if I'm not mistaken. This slot should be slightly... should be slightly more forward, and or maybe not, maybe that's actually in the same spot, but this has a recess in it, so the screw head will fit down in there just a little bit better and will help engage those screws. So I think those are the main changes that were done with this. So we're going to take our square nut, zoom back out just a bit, I guess. It just goes in that slot right there. And M3 by 25 is what we want. I think is one of the things we were short on. Let me grab my kit. Now, I feel like I had a way better camera setup last time. I feel like this isn't working for me quite as well. So I'm not trying to fit around it. So now this can engage without any trouble. Come on. And we're just going to go ahead and get it started. Don't tighten it up yet, but that's going to... I'm still missing. Did I move this out too far? That's just what I've got. So again, this is going to clamp down and hold that rod in place. But we're just going to leave it a little bit loose for now, but just get it engaged. And you know what? Let's just go ahead and do all of that right now. Get it out of the way. Move this back over here. Yeah, I'm trying to fit the printer and my working space all together. That's just not working. So let's just choose one or the other here. These ones have wanted to cross thread, so I'm going backwards. There we go. The other one wanted to cross thread too, so be careful with that. Hey, Juma. Good to see you, man. Am I saying that right, Juma? Juma's got a build going in the Discord server. It's been interesting and awesome to see his progress. All right, it looks like this is the one where I did get that set. Awesome. You guys ever known someone, worked with someone for a while, saying their name one way for a while, and then eventually one day they correct you, and you're like, I've been saying your name wrong for like a year, and no one stopped me? Egg on my face. Happened one time with a client that we worked with, at work no less. Saying his name wrong the whole time, and no one dared to correct me until one day my boss pulled me aside. He's like, you know you're saying that wrong, right? What? No way. Nobody told me? So yeah. Breaking taps, yep. He got a pretty funny picture in the Discord. He broke one out pretty badly. All right, so now we've gotten that ready. So this is gonna go. I mean, this is all good on the main camera, so I'm not gonna try to get too close up with that right now. Oh wait, I didn't. Oh, these are these need reinforcement screws, right? What are those? Might as well get that done while we're here. I'm looking in the wrong place, I guess. Or looking on these. What? Oh, oh my goodness. Looking in the totally wrong spot. Okay. Right up here. M3 by 25 there too. Just to confirm that's in. Wait a minute. Is this just on some of them, Chip? Or am I just, maybe my cat is a little. Oh no, okay. Okay, we'll put that in later, Chip says. I don't see it in the CAD though. Is this new? I just don't know what size to use. I think I'm looking at an old CAD. Yeah. I'll have to get the new CAD file, the new step file in there. If you can tell me what it is, I can get it in there. But if these can go in after, that's totally fine too. Because yeah, that's what I'm looking at here. What I'm looking at here is we're looking at new and old, and it has a spot to put a screw in there, and that's going to help reinforce this. So we'll put that in later. We'll figure out which size it needs. That makes it real easy to tell which ones are new and which ones don't. These ones got belly buttons. So hopefully our alignment is all still pretty similar, but we'll still probably have to do it one more time. Oh wait, before we do that, let's replace this one down here too. Actually, I should have done that one first so that doesn't happen. So we're just gonna match these up, so we don't have to think too hard about which ones go where. I think I printed these with a little tighter settings. There we go. What did we learn last time, guys? Work with gravity, not against it. Put the bottom in first, and then it's not going to slip out. Which is really the top because the printer's upside down. Oh, these are two different screw sizes. Make sure you get the right kind. Longer screws over there, shorter screws right here. This is much easier if you do this the alignment procedure without a motor. If you've got one motor, you can still kind of get away with it. Just going to bring it all the way to the bottom. Hopefully that doesn't throw us off too much, but if it's not aligned, I'll do that off stream because you guys have seen me do that process way too many times, I'm sure. I did replace that bearing though, where I knocked a couple balls out of it. So that's all good and ready now. So it's one of these. And we're just going to leave the bed at the bottom throughout this process, and then I'll raise it back up to align it later. What the? Yeah, these are a little bit out of position. Darn it. Oh, man. It tried to pop out here. There we go. We got 5 concurrent viewers, it looks like. I think that's a new record for us, guys. It's exciting. Okay, so we're leaving that a little bit loose for now. You guys still see... Move this back over the other way now. Yeah, nice. So we just did this one. So we're working on this one over here. Well, let's take the top off first. There goes the square nut. Go over here. Just take this out. Same thing we need to match this up. I think one of these is new, just a little bit new. But yeah, this one's going to go on the right side, I believe. Set that over there for now. In fact, actually, I think both of these ones will. Okay, so this is the part we need. I'll leave this loose for now so we can still get the rod back in there. There we go. Nice thing about having these screws in place here is the square nuts don't fall out either. So definitely this is the better way to do it. And we're leaving our top loose. Don't need to tighten this right now. We're just kind of tightening the bottom ones because that's our reference spot. Okay, one more side. Wait, we learned work with gravity, which means take the top off first so it doesn't drop once we take the bottom out. The rod. Okay. Now, which one is which here? It's going to be the one that goes like so. So I believe, yeah, this is the bottom one. Wait, don't tighten these up very much at all yet. the rod in here. You know what? We'll get the top kind of set in place too before we tighten the bottom one. Uh-oh. Is that gonna fit? Yeah, there we go. There's another. This is what was going on. This little nub was not fitting in there, but it was just because the roll-in nuts had gotten a little misplaced. There she goes. Okay, now we're going to tighten this guy up. Actually, you know what? I think the alignment procedure the chip had did... No. We did start with the bottoms here. Or the tops, rather. I'm getting all turned around, guys. Okay. Now, I would like to believe that is still aligned and square. But I don't believe it is. So what we're going to do... If I put all the motors in now, then it's going to be a lot harder to align the bed. So I lied. We're going to go through this one more time. It's going to be the easiest way to do that. We just drop the motor, but leave the mount in. We can get away with that, I think. Right, Chip? I'm sure you could maybe get things aligned and squared with the motors in there, but it's going to be a whole hell of a lot more difficult. Well, we can't just drop the motor because two of the screws are... If I can get a view here. Two of the screws are not accessible due to the extrusion. I'm not sure if you can see that right here and here. So we're just going to undo the mount instead of undoing the motor. Actually, it looks like I never tightened it in the first place. So we're not losing much here. Yeah, that's what I thought. Thanks for confirming that, Chip. At least we caught that now instead of installing all the motors and realizing, why does my bed binding up? What's going on? Then Chip would tell me, do you know how any of this works? You can't align it if you've got... if you're not able to move it all up and down at the same time. Also, we're going to get to see a new tool that Chip made for me. A jig to help with getting these installed a little bit easier. He saw me struggling on the last stream. He said, that poor guy. Let's get him a jig. Let's make this easy mode. Make it foolproof. Okay, so now... You know what? We're still pretty close there. Oh my goodness! Spring's doing spring things. Who would have guessed? You bounce a spring and it returns. I really like that. But on the side. You see that little rebound? That's awesome. But we only have one set tight right now. So just a moment. So even though this feels pretty good, we're just going to follow that procedure one more time. Flip her upside down. We start on what would be the right side if you're looking at front ways, which is really just the one with one side. So this already was kind of aligned when we did that. So we know that our bottom just realize you guys can't see anything that I'm talking about. No, I just had the window up. You probably could see that just fine. So we're nice and nope. Nice and tight here. That's our reference. And then up here. Did we tighten this? Oh, yes, we did. Okay, so this is, I'm just going to do this one time here. Loosen loosen this. Get all the way to the top. Might be doing this a little bit wrong, but the right side is the reference part. So this needs to be as straight as we can get it. Everything else is going to rely on it. This is why we're just double checking with the feeder, even though like sometimes you think, yeah, no, I know what I'm doing. I'm thinking about this right way. Sometimes you miss it. Yeah. That's all assuming that we have the right distance here. Hold on. Oh, right here. Look backwards. No. So we're gonna undo this and we're gonna straighten this out, do it right. I was moving it up and down, but that's not the way to do this. I knew I was missing something. It's like this feels different. This feels wrong. Okay, so that's nice and free. This is the old alignment tool. There is a new version of this with some updates. So we're gonna push this into that, and then we're gonna push, remember, outside, so that this the lip on the other side of this is square with the extrusion. Get it set. Then go in for the kill. Loosen this guy up. Nice and loose. Oh yeah, see this was way off. This is how you can tell if you're truly straight up and down. I think this one does have got a little lip on it as well. That's a new update. And that's going to help, again, just keep things nice and square. If things aren't square or not in alignment, you have so many other issues down the road. Okay. Still feels about the same, but these ones I can feel are a little more crunchy now. So back over here. probably should have had these loose while we were doing the other side there, but I think we're fine. These still loose? Yeah. So we're going to loosen all this up. Sure, we have some movement there. We can all move. Move up and down a few times. And you'll notice, if you pay attention, this moves as you go up and down. They all do. So we're going to leave it at the bottom. Then we're going to tighten very carefully. Don't worry about pushing this one in, out, one way or the other, because the distance between these two pieces is not going to be perfect. So if the piece looks like it's a little bit further pushed out than usual, that's fine. Just one thing I've noticed is while you're tightening things sometimes, if you're tightening one side too far, the part itself will twist. So try not to let that happen while you're installing this. I think the best way to avoid that is just to tighten a little bit on each side evenly. Don't over tighten one side right away. We'll go with that. We're going to move up and down 3 more times. Oop. Okay. Yeah, that's why we use washers chipsets, so that hopefully will slip on the washer, not twist apart. Did that already? So much better, just from those changes alone. So now we're gonna put it up here. We're gonna see if we can. How did I do this before? Hold it in position, maybe. Either that, or if I turn it on its side, I'm worried that it'll be skewed in one direction. So I'm gonna raise it up and hold it kind of in the center. If you hold it on one side again, it's gonna droop on one area. We're gonna tighten a little bit here, a little bit there, a little bit here, a little bit there. Go back around. By the way, I'm not sure if it matters, but if you've noticed, I'm tightening the inside screws first, these ones. I don't know if that matters, but the idea is that's going to lock in the distance between these two, and the outside ones are really kind of just reinforcing that. I don't know. Maybe that's just something that makes sense in my head, but doesn't actually translate to reality. Let's check in, make sure that's all feeling nice and torqued down. Like it. Final test. Great. That sounds good. And now we know, I'm sure, we're good there. Nice. Just realized I have a little bit of a loose grub screw here. This is the one I was replacing earlier, and I don't know if I got it all tightened back down after. Oh yeah, wow. This one's about ready to come out. A lot harder to do once you've got the the motor mount in. Chip, would you check these on yours? I've been finding that they are coming loose a little bit, but I'm afraid to torque them down too much. I'm curious if after a little bit of use, if they're gonna end up coming loose. Not sure if that's a problem you've seen in yours or not. You can also add a little bit of Loctite if that's a concern. Every time I lift from like one direction a little bit, it feels a little crunchy. But as soon as I even it out, yeah, the crunch goes away. So I like it. It's paranoids me every time I feel it dragging a little bit. Yeah, either a thread locker or, you know what, I was almost kind of thinking, you remember the clips I was showing you to lock the belts in on the tool head? I'm wondering if something like that could also work. You know, basically it was just an adaptation of your panel clips, but if there's a little clip that has some spring loaded tension in there to, again, just like you say, touch that the bearing and lock it in. I don't know. That might not actually work as well as I'm thinking about it in my head, but that was one of the things that came to me as I was drifting out to sleep the other night. We're gonna do this upside down again. Uh-oh. Why do I have extra screws here? What did I not? Oh, is this for the motor mount? Sorry. You guys ever work on cars? You come up with extra screws and everyone's like, yeah, weight reduction. You're like, yeah, what's gonna fall off next? All right, let me see if I can find that jig. There we go. So I haven't used this yet. Let's see if we can figure it out. So the piece that threads um, onto the lead screw is going to fit down inside of here. And now that I know that we have a good view, the rest of this, let's lower this back down. So this is going to fit down inside here, and that's going to help keep it in place with the spring. So as we thread this on just a little bit, actually, you know what? No, let's put it in place. We talked about making those marks in the last stream. Not sure if they're still here. Yeah, there. And I think this goes from the outside. Let's check. Need to adjust this really quick. Cool. I think this is going to go on the outside. Yeah, and it's going to help hold that in place. Yeah, I like that, Chip. That's solid. Then as we put this down on top, we just screw that in. I don't have a close-up of this, but and that holds it together so that our parts, the two decoupled, what I'm looking for, palm nuts, will stick together and won't rotate out of sync. I don't even know if I described that right. But once you have it in there, you can actually just hold this in place and turn this up and down, and that will raise or lower the part. So just get it kind of locked down to where that's in there. At least this is the procedure I'm doing this time. I think it works pretty well. Man, you know, I thought this was going to be a short stream, but I'm glad to see it's about right. Now with these, I don't know, Chip, do you recommend leaving these loose, getting all the motors installed, and then like raising it up and aligning it, or does that just not matter as much since it's using an Oldham coupler? Just trying to let it fall naturally where it wants to, at the very least. We'll get going on the other ones while we're waiting for him to respond. Now, Chip did recommend taking a look at these, making sure that there's no sawdust in here. They look pretty good to me, but give them a nice blowout. And let's double check and make sure our palm nut goes on there without any restrictions. Yeah, no issues whatsoever. Just gonna get these two set. And might as well double check the other one as well. Yep, see? We can turn that one finger. Oh, it gets a little catch there, but again, that's just because I'm pushing into it on one side. But that, see, like even down here, like it just takes a little bit of effort, but we can still, one thumb, screw that off. Yeah, okay, move the bed to the bottom. So in this case, we're going to be moving it up before we tighten that up. So we'll get them all installed and then move the bed and then tighten them at the final spot. Now to make this a little easier, I can turn this upside. I'm just gonna do the mount the motors to the motor mounts first, and then we'll install them to the frame. But I want to make sure I have that in view. Looking at this, remember we want the wiring to face the back of the printer, so you know, kind of line it up, think about it. Okay, this is gonna go like so, or in this case, it's gonna be upside. Do I have these all wrong? Yeah, I think these go the other way. So it's gonna hold it in place like that. We're going in like that. I wonder if Chip, if I mean, these are all just little asks, but a small indicator on this showing where the wiring would go might be kind of helpful. I mean, it's not even a big deal. Like you can always adjust it later, but just something I'm thinking about right now. Feels like it wants to cross thread, but I just think it's binding a little bit. There we go. Just don't screw it in too many turns on the first one. Just get it started. Back to it. Yeah, welcome, Okano. I don't know what a DLL PDF frame is either. This frame is part of the sample kit that Fabrico put together. So this is a pre-production kit that we're building with. We're building it with the pre-production kit to make sure that we find out any bugs or if we're missing fasteners. We've already found a few things that we want to change before it goes to full production. So this is all provided courtesy of Fabrico. Hector over there has been absolutely great to work with. And that's what we're doing. It looks sparkly, huh? No, I mean it's really high quality coating though. Like even the ends are coated. Um, I think we had we did have a couple of issues with just getting some of the quality worked out, but by the time you guys get production kits, you'll be you'll have some really high quality parts. I don't know if you were here. If you go back and look at the first stream, we went through all of the components that'll come in this kit, and they're really good stuff, man. Like I'm excited. Like genuine Gates belt, um, full Sherpa mini extruder with the body. I mean, I've got it right here. I think this is injection molded, but it's very, very light. I don't know if this is nylon or what it is, but this is a high quality motor kit. So yeah, everything that you get in there will be very good stuff. We're gonna have to check out those custom aluminum frames you were talking about, though. That sounds cool. Okay, same thing. If we're looking at this, this should go on exactly the same way. Oh wait, no. Okay, let's take these out. We don't need these right now. Right? So if we do it like that, yeah, perfect. There are options for panels. It won't come with panels. This is if you're not familiar with it, this is going to be a Mark III, a Prusa Mark III to Core XY conversion. So the kit we're talking about is just going to be the parts needed for the conversion. You'll still need a donor Mark III or to source some of those parts yourself if you want to build it off from scratch. But looking over here, if we just show everything, and this is what the panels would look like. So it is semi-enclosable. The top would need a little extra room, maybe a top hat. But for me, I'm building it as an open frame printer. I've already got one that can do enclosed printing. So this guy's goal is going to be, showing the Mark III conversion, and maybe there'll be some extra goodies we add on later, but we'll have to see. But it'd be really cool with this project. This is able to save a lot of Mark IIIs from the junkyard or just from sitting on shelves collecting dust. If it can be reworked into a modern Core XY printer with, you know, all the bells and whistles, it'd be cool to see some of those printers upcycled and saved from the eternal bliss of the junkyard. Okay. Our jig here, we're gonna get that ready. And actually turn the camera back on. Oops. It's easier if you get the jig set like so. Lining this up is still a little tricky. You got to make sure you know where you're at. Once it's in there, just take this over the top, push it down. Oh, I guess it wasn't quite caught in there. Okay, now it is. I didn't do it right though, because the nut obviously came up. So let's undo that. Once it's lined up, try not to twist it as you push it down. Try not to cross thread it, so go backwards until you feel it grab. That feels better. Yep, perfect. Now, adjust it down so it gets into place. No, the Mark III is i3 style. It's a bed slinger, man. Two motor Z axis, and the bed moves in the Y direction. Or no, yeah, two motor Z axis, one on X. It's been I don't want to say ripped off. It's been it's inspired a lot of the other popular 3D printers like the Ender 3. Pretty much just a clone of, well, very much heavily inspired by the Mark III. You can say that at least. So this is taking one of those. The Mark III is a little bit outdated now because they have the Mark IV, but still a lot of good ones out there, and it's a great machine. It's just, you know, not necessarily the latest tech that you can get in your 3D printer, so they're probably not getting the same love with the owners as they, or Mark III owners probably aren't using them quite as much as they used to. So this will give them an option to upcycle it and continue using it. Core XY. Oh no, I think Chip. I mean, Chip can talk a little bit more about it. He's the designer. I'm just a beta tester and uh, live streaming it. Oh crap, I didn't get that in there all the way. Back it up. I thought I had it, but I guess not. Okay. I think I prefer putting this down in, getting it started by hand. Just a couple turns. Take it out, line the tip, start pushing it down in there. Oh, and see how it's going to kind of try to come back up. That's the problem we ran into last time. So that's why we use the jig. So once we're kind of down there, line up the tabs, use the jig, hold it in place. Okay, we're in there that time. No more games. Okay, I'm just gonna make sure these are loose, but tight enough where they're not gonna fall out on me. Okay, and as you see, we've got all of our wiring clips pointed to the back of the printer. Make wiring a little bit cleaner. Flip this guy over. Haha! Look at that, guys. Told you. It's always really exciting once you get a little bit closer looking like a real 3D printer. I love it. So, get this to the bottom. It's going to be a very slow process. Feels like it's binding a little bit, just trying to give it enough room to work here. You could probably do this easier if you just hook up a printer board, run all the motors in the same direction, but I don't trust that if I know things aren't quite squared up yet. I can feel the motor's trying to adjust, so I'm just kind of give them a little wiggle, little shake to let them center themselves. Once we tighten these motors up, we're going to call it a day, guys. But I've been saying we're finishing the Z-axis for how many streams now? It's good to finally see it coming to an end. I think these might be just a touch too tight. Having a hard time adjusting themselves. I didn't want the screws to fall out, but I don't think we're at any real risk of that. And if they do, oh well. Oh, wrong one. There we go. Let's not bend our lead screws before we even get this thing going. There we go. That's a lot nicer. Okay, so we are sitting on the rod mounts here. We tip it over, we can actually see. Chip, do we want it to be touching all the rod mounts? And that's going to act as our square? Or is that really going to matter here? And what I mean by that, just so we're clear. Unplug this, it's actually using Wi-Fi. What I mean by that is, come on, right here, I can twist these until this gap is basically touching. Is that going to act as our square, or do you think there's a better way to do this? Cool. Well, we're just going to double check that. See, this is awesome. If you can see these two, I love it when things line up. We see the gap here and here, and they pretty much close and touch at the exact same time. And that's what we want to see. But we don't want our motor to bend in like that. That's not great. But as we hold that in place, this one over here is touching a little bit sooner. That's okay. In the spirit of the original alignment procedure, we're going to tighten the right side first. Or actually, no, not the right. This isn't the right side. This is just the one that has a single one. But holler at me, Chip, if I'm screwing something up. Like that. Cool, cool. Okay, let's see, guys. Yeah, I think that feels pretty good. It'll be, I can't turn all of them at the same time, but they all feel pretty nice turning there. Um, Once it does bind, of course, when one's too high, but as soon as I get it back level again, it feels good again. Yeah, I'm gonna have too much fun playing with this. No, I love this part. This is so cool. All the engineering you've put into this chip is just phenomenal. Um, we're not gonna put the actual hotbed on yet. Again, we're saving that for later. Next stream, we will be doing probably the X gantry. Maybe we'll do the tool head. But this is awesome. I'm having a lot of fun with this. Cool, guys. Well, let's call it a night. We'll pick this up either tomorrow or the day after. I'll try to give you a heads up earlier in the day. But